We are continuing on with our word problems that we started last class. It's just sometimes what they do is it's a system word problem where you're going to get two equations like we had before. It's just what's going to happen is you're not going to get the two equations right at the first part of the problem. Sometimes it's going to be a little bit further down in the problem is when you're going to get your second equation for you to solve. So we're going to go through some examples like that today. You're going to see some like that on your homework. So our first problem, we have Jonathan has 9 bills in his wallet that are either $5 bills or $10 bills. So this table that I have right here under part A, this is just a table I created to try to help us think through this problem here. So Jonathan has a total of 9 bills in his wallet. So if 0 of the bills are $5 bills, how many $10 bills would he have? If he has 9 total, 0 of them are 5s, how many of them would be 10s? 9. So then if I were to figure out the dollars amount, how much money would he have in his wallet here?
$90.
$90. Alright, so if he has one $5 bill, how many 10s would he have? 8. Because again, this has to stay equal to 9. He's got 9 bills total. So how much money would he have if he has 8 10s and a 5? What was that? 85. Alright, so what if he has 2 5s? 7 10s. Total amount would be? $80. So if he has 3 5s, how many 10s? 6. How much money total? 75. If he has 4 5s, he would have 5 10s, so how much money? 70. There is a pattern. If he has 5 5s, he has 4 10s, and how much money? 65. So really, if I were him, I'd rather have 9 10s in my wallet because I'm going to get a lot more money than any of my other combinations there. Okay, so part B says if F represents your number of $5 bills, so this is basically giving us a let statement. F is the number of $5 bills. T is the number of $10 bills. Then what does this mean right here? 5F equals 10T. Does anybody think they know? 5F equals 10T. They are the same amount, but what's the same amount? Yeah, the value of your 5s is equal to the value of your 10s. I should have written smaller. Oh well. So the value of your 5s is equal to the value of your 10s. That's what that equation right there is mean. When they say 5F, they're doing $5 times your number of 5s is equal to 10T, $10 times your number of 10s. So that's really all we could figure out so far. Knowing he has 9 bills in his pocket, you can't really figure out anything else in that other than what are your different combinations of numbers that you could possibly have. So part C, they're telling us if he has a total of $55, set up a system of equations involving F and T that could be used to determine how many of each bill he has, and then solve the system. So our first equation would be your F plus T equals 9, because his $5 bills plus his $10 bills needs to equal a 9 because he's got 9 bills total. What would our second equation be? Does anybody know? He's got a total of $55. It's going to equal 55, yep. But what equals 55? What does our F mean? No. 5 times your F, because it's $5 times your number of $5, plus what? 10T, $10 times your number of 10s. Money plus money equals money. That's what we were talking about last time. So which one are we solving for? 5s, 10s, or both? Both. We got to get both of them in the long run. So it doesn't matter how we solve this one. I would start by multiplying this one times a -5. So that would give me a -5f minus 5t equals a -45. Remember to multiply everything times that -5. So then I'm just going to rewrite my second equation there. Underneath it, lining up my f's, lining up my t's, lining up my numbers. So then when I add them together, what happens to my f's? Canceled out. They're eliminated, hence we calling that the elimination method. -5t plus 10t. Yep. And then -45 plus 55. 10. So 5t equals 10. Divide by 5. And t equals 2. So that means we have 2 $10 bills. So how many $5 bills does he have? Plug it back into, I'm going to plug it into the first equation. So f plus 2 equals 9. So f would equal 7.
7?
Yeah, subtract your 2, we get f equals 7. So what's the last thing we'd have to put here? They gave us the problem in words. We have to write the answer in words. He has 2 10s and 7 5s. So Kyle, he could buy 7 something smalls. No? All right, so let's look at part D. It says, let's say we were told that Jonathan has 7 bills, so we're changing the problem just slightly. So instead of 9, he now has 7s, and they're all 5s and 20s. Now he's got 5s and 20s. We're also told he has $120. Set up and solve a system to help evaluate whether we could have been told true information. So we need to first set up a let statement because our letters are changing a little bit. F is still going to be your number of 5s because we still have $5 bills here. This time, though, what is t going to be? 20s. So let t equal number of 20s. So now we need to create our 2 equations. He first has a total of 7 bills. So what would that equation look like? Our 5s plus our 20s equals 7. F plus t equals 7. So now our second equation is going to be the money one. How much are our 5s worth? 5. I kind of gave you the answer. How much are our 20s worth? And he has how much total? 120. So now we just got to solve it like we would any of our other ones. So what am I going to multiply times?
5.
Yep, -5. So I get -5f minus 5t equals -35. And then I just rewrite my other equation underneath it, lining up my f's, lining up my t's, lining up my numbers. So when we add our 2 equations together, what happens again to our f's? They're gone. -5t plus 20t. And then -35 plus 20. Nope. 85. I'm going to move that up here. I'm kind of running out of space down there. So what's our last step to get our T? Yeah.
And that is 5.6.
Isn't it like 5.6 repeating?
Yeah, 5.6 repeating.
So then, since we got 5.6 repeating, can we have 0.6 repeating of a $20 bill?
No, it has to be 5.
But it can't be 5. My answer is 5.6 repeating. 5 wouldn't work. So were we told true information?
No.
No. This is not true. Sometimes you can't just round, and this is one of those times with a system, it has to be that number. It can't be a different number. So because that's not, you can't do that. It's not true information. So now this problem right here, this was right off of a Regents exam. So I always like to show you these kinds of problems so you can kind of see what we're going to be seeing in June on your test. So we have an animal shelter spends $2.35 per day to care for each cat and $5.50 per day to care for each dog. Pat noticed that the shelter spent $89.50 caring for cats and dogs on Wednesday. So write an equation to represent the possible numbers of cats and dogs that could have been at the shelter on Wednesday. All right, what's the first thing we need here? Let statements. Let's see equal number of cats. We know how much it cost for cats. We don't know how many cats they had. Now what should our other let statement be? The equal number of dogs. So now this is one of those equations where they didn't give you enough information for you to write 2 of your equations yet. You only have enough information for one equation, and that's our money equation as we call it. It's $2.35 for each cat. So $2.35C. Plus how much for each dog? $5.50 for each dog. And they spent a total of $89.50. That's the only piece of information we know at this point in time. So that's the only equation we can write right now. So then our next part tells us that Pat said there might have been 8 cats and 14 dogs at the shelter on Wednesday. Are Pat's numbers possible? Use your equation to justify your answer. So what do you think we should do? Aaron?
You should use 8C.
Put 8 in for C. And then put what in for D?
14 for D.
Yeah.
Oh, I was definitely doing it wrong then.
That's okay.
Because I thought you were making another thing.
No, we're not making another equation yet.
Okay.
We're just checking to see if these numbers work.
I'll say if they work in about 10.
All right, well, what's 235 times 8? Use a calculator. Multiply it out. What is it?
20.
No, it doesn't work.
Oh, 18.8.
18.8.
For some reason, I was registering 81 in my head. I'm like, that's not right.
That's too many.
18.8. All right, 550 times 14.
That's 77. 77 plus 18.80 is 95.8.
95.80. Is that the
Doesn't
same
work. Not
as
true.
89.50?
No.
No. So, the problem being is everyone on the Regents exams, they did all that beautiful work, but you never actually answered the question. You've got to make sure you answer the question. The question being, are Pat's numbers possible? So you just need to write no. I had to take a whole point off for them not writing no. I was so mad when I graded that exam. So mad. But you have to answer the question, so always go back and check to make sure you've answered it. Okay, so later, Pat found a record showing that there are a total of 22 cats and dogs at the shelter on Wednesday. How many cats were at the shelter? There's our second equation. Now we can use our substitution, our elimination method. Our second equation is going to be cats plus dogs equals 22. There's a total of 22 cats and dogs. And then you're still going to use your equation from the first part. So there's our system. I would use the elimination method for this. The question only wants to know, though, how many cats there were. So what should I multiply this first equation times? Negative what? 5.50. What's in front of D in the other equation? That's what we want to multiply times. So I get negative 550C minus 550D equals, I think that's a negative 121. Somebody check it for me. Negative 550 times 22. Negative 121. All right. So I'm going to write the other equation underneath. So then we're going to add our two equations together. So negative 550 plus 2.35. Negative 3.15. Good. Our D's are gone. They eliminate each other. So negative 121 plus 8950. I know it's going to be negative. Negative 31.5. So then divide by our negative 3.15. What'd you get for C? There you go. So we just have to write our sentence. There were 10 cats at the shelter on Wednesday. Oh. Alright, so let's take a look at our last one. We have two cell phone plans offer differing text packages, and the two plans are outlined below. We have plan A, which is $5 a month plus 0.03 per text. That's 3 cents per text message. And plan B is no charge per month, but then it's 10 cents per text message. So they want to know, is there a certain number of text messages when the two plans cost the same amount? Well, we don't know yet. We got to go through and figure it out. That's what the second part is telling us to do. So we're going to have just one let statement here. And that's going to be let x equal the number of texts, because that's what we don't know. We don't know how many text messages a person is sending in a month. So plan A, they charge you $5 a month plus 3 cents per text message. So 5 plus 0.03x is what we're going to have for plan A. Where? It's a colon. Colon. No, there's nothing equal here. I'm writing expressions, which is why I'm using colons. Mm-hmm. All right, so plan B, no charge per month, but it's 10 cents per text message. So how would I write that? It would just be 0.10x. So there's no plus or minus anything because there's no charge for the plan. We are looking for when they cost the same amount. So what was my equation going to look like? Their costs the same. I need to set them what? Equal to each other. So plan A, we got to see when it equals plan B. So in order to solve this, I'm going to subtract my 0.03x. So I have 5 equals 0.07x. What do we divide by? 0.07. And what do I get when I do 5 divided by 0.07? A long number. What is it? Starts with a 71, doesn't it?
Yeah.
71 point.
4,
Then what?
2, 8, 5, 7, 1.
All right. That's good. So then my question for you is, they are equal when you send 71.428 text messages. Can you send 0.428 text message?
No.
No.
Round it down.
But if I round it down, then one plan's going to cost just slightly more than the other one. If I round up, then it switches, and again, one plan costs more than the other one. So will they ever actually be exactly the same?
No.
No. No, they will never be the same. And sometimes that happens. Again, sometimes rounding does not work.